I'm June Adams, the CEO. I'm here with James Cleo, who's going to take over in just a few minutes and do a demonstration. We are filming today, so we hope that's fine with you. We just want you to know that we are always here to answer your questions. We'll even look at your projects for you and let you know if everything's okay or something needs to be fixed. So let's get started. What is PowerCalc? PowerCalc is patented electrical design software that automates the design of the electrical distribution system in a building, all in compliance with the National Electrical Code, and it's for new construction or renovation. It's also great for facility management. PowerCalc makes electrical engineering easy, fast, exactingly accurate, and very green. We've bundled 7.5 million equations, and essentially we've automated the NEC. You'll save at least 40% in design time, and we're very different from other softwares. One of the reasons we have a patent is because we design from the bottom up. In other words, from the circuit to the service entrance to the building. So everything you input into PowerCalc is based on actual numbers. It's never estimated, except we'll show you when it is an estimate for your design build projects. Now, other programs design from the top down, and everything they do is based on estimates from the frame size, the transformer capacity, feeder sizes, etc. So we want to make that very clear. For us, you input just 3 things for each circuit, and then that's it. You get over 300 NEC compliant outputs. Everything is a great big integrated equation, essentially, these 7.5 million calculations. And that means a lot of good things for the user. Any change, it automatically updates the entire design, upstream and downstream. We can automatically generate the one-line diagram simultaneously with while you're designing. And we are the only design software that's in the cloud. And we got Product of the Year from Consulting Specifying Engineer in both 2016 and 2019, one for the cloud and one for the one line. Because we're in the cloud, it's very easy to collaborate, and you can use the software anywhere on any device, so even at the construction site. As I said, I'm just going to give you a quick overview of how PowerCalc works, and then James is going to get demonstrating. Again, 3 inputs per circuit for over 300 NEC compliant outputs, load KVA, load type, and number of poles. And all the NEC compliant data is in our proprietary database, so there's really no reason to ever open the NEC handbook again. You can input on the panel, or we have wizards, and James will show you how it's much faster on the wizard. And with that, I'm going to turn it over to James.
A typical one-line diagram that is developed automatically by PowerCalc, the software, the application. This here is for a water treatment plant, so it's a little bit more complicated than the typical office building or shopping center and those sort of things. You can see that I have a main distribution panel, 2 motor control center with a tie breaker in between them. And as you go down the one-line diagram, you see the distribution. And I have also 2 unit substations with an enclosed circuit, transformer, 1500 kVA transformers, and then it feeds the rest of the distribution in the power plant. Some of these also includes the generator. So if I click on here, it will open the generator circuit. It shows you the automatic transfer switch, and it's hooked up on the normal side to this circuit here on the USS 1A, and on the here's the load side, and already automatically by itself realized that the connection on the normal side is a higher voltage than what the panel require, so it will go ahead and put also the transformer for you. So how did we get there? Like June indicated, we have a format of starting from the bottom up. So to come up with this one-line diagram, we need to start putting starting the power distribution system. So now I'm going to change screens. So to To start the project, if you are on one of the users of the application, you will get your own container that's going to have all your projects in it. But to start a new project, you just go ahead and click on the new project, and you name the project. And let's say go ahead and call it the 200710 demo. And that's really all you need to identify that project, but other things that you can use internally, like the project number and the client, you can add all that later on. So you click on Start a New Project. Now you start building the database. So you start having the project information. You can add whatever other information that you might need to identify that project. Now, so to start, you start by clicking on the control panel. It will open the dashboard for you in here, which is a blank power distribution tree. That's what we call it. You look at the left side here, it has the plus buttons. These identifies each type of panel. This is one here for the distribution panel, automatic transfer switch, generator, panel board, which is your typical lighting and power panels, and then building equipment, motor control centers, fire pump, and so on. So let's say that this particular project is going to be, say, an office building. So we're going to have a couple of distribution panels and maybe a generator, and then lighting and power panels. To start, click to load a distribution panel, click on the plus sign. It will open the first panel for you, and it automatically takes you to what we call it the wizard, which this drop down or this window here, you see that consists of 7 regions. Each region has its own fields. Each field has a drop down menu for your selection to set up that particular panel. So you also notice that some of these fields or the drop downs are set on auto. If it's a new project, leave it on auto, and the system will react to every input that you put on that particular panel. And then update these values for you based on the input. So the default for the distribution panels on the voltage under the characteristics is 480. So we're going to assume it is 480, but if it's any other voltage, you can go ahead and click on the drop-down menu and click on it, and it will set up the entire panel for this particular voltage. If the voltage is not on the drop-down menu, we have a mechanism for the user to access the database and add voltages that, like the overseas voltages and that sort of things. We also have the button in here for metric and US units. So also that can change, or you can flip-flop between the US units and the SI units anytime you want to. So we're going to assume that this panel is 480. We're going to leave the AIC on auto, and the system will calculate it as you add feeders and you add panels. It will go ahead and automatically calculate all the AIC ratings for you and the fault current and all that stuff. The other thing that you look at down here, the feeder, again, it has its own fields from the wire gauge, the conduit size, the ground. Again, leave them on auto, and all this here will change as you input the circuit by circuit. The temperature, 65 and 90. Material, copper or aluminum, and you can come and change any of these values, any of these settings, anytime during the project. The only other thing that you would like you to pay attention to, again, the ambient temperature. The default is the 30 degrees as identified in the NAC or required by the NAC. For other locations, especially like in Saudi Arabia, I think I used 55 or 50, I can't remember now, but you can go ahead and set it up on 50, and it will react to that change and update everything upstream, downstream on the entire project based on that setting. So let's say that this distribution panel is actually 12 spaces. So we're going to go ahead and change the 6 to 12 and close and calculate. It's going to go ahead and open more spaces for you as you requested. You see that it's set on 480, and there is no feeders, there is no any branch circuits yet because we have not really put any load. So let's go ahead and start putting some, well, actually just go back to the control panel and add another distribution panel. It'll be the same way. You go ahead and add the distribution panel. You get the setup screen. You can set it up any way you want. And let's go back and to the control panel and set up a couple of panels, panel boards. It would be the same methodology to set up a lighting or a power panel. You notice that the default on the lighting and power panels are again the 208. You can go ahead and change it by just clicking on 480 and say that the number of spaces is 42 and click and close and calculate. It's going to go ahead and open more spaces. So now I have a 42 panel spaces. Yeah, again, you notice that, which is almost the same setup on all the panels, that the panel is broken down into 3 sections. The header, the center, where your branch circuit goes in, and then the footer, which is your demand calculations and load calculations. All right, now let's go ahead and add a couple of more building equipments, and then we're gonna start wiring things up. I'm going to start with the building equipment first, and then we'll go to the lighting panel. It's always recommended that for each piece of equipment in the building is to have a separate worksheet. So let's say that this one here is going to be air handling unit number 1. And it's going to have a fan. Okay, and I need, again, to get it to work, I need about 3 inputs from you. So this is going to be the fan, so it's a motor type load, and it runs at 480, and it's a 3-phase. And from the mechanical engineer or the equipment cut sheet from the manufacturers, you can get the horsepower or the full load current. So this is a 10 horsepower. After that, we're gonna go ahead and click calculate. Once you clicked on calculate, it calculated the NEC full load amp, and then for the cooling cycle and the heating cycle, calculated the KVA. Down here, calculated the feeder size. I don't know if you guys can see it, was it too small? I enlarged it a little bit. So here's the feeder size. This particular unit will require 3 number 12 and a number 10 ground conductor. And the circuit breaker is 35 amp circuit breaker. And on the fuse disconnect is 25. Now let's say that that fan, we discovered that it also has a heater in it. So we're gonna go ahead and add the heater. And it's a heater circuit. It's also 480, 3-phase. And it is 12 kVA. And the fan is going to be running in the cooling cycle and in the heating cycle, since you have a heater in the air handling unit. If you notice here, without the heater, you just put the fan load in the cooling cycle. There's nothing in the heating cycle. But once now we're going to do that, it's going to go automatically and calculate the total load for the heating cycle. So now it calculated the heating cycle. Oh, I'm sorry, I did not put the H in here for the fan. So now I have a calculation for the heating cycle and the cooling cycle, and it calculated the feeder for the cooling, heating, and the feeder for the heating, and took the largest of the 2, and same thing for the circuit breaker and the fuse. The last thing that we need to do on this particular piece of equipment is to connect it to the power distribution system. Now to do that, go to Fed From, select the drop-down menu. It will show you the panels associated that you can actually connect that unit to it. Let's say we're going to connect it to panel DP1. It gives you this available circuit. We're going to go ahead and connect it to circuit number 1, submit. Now that air handling unit became part of the overall power distribution system and is connected to distribution panel number 1, circuit 1. So if I go to it, here's my air handling unit. Here's the feeder, the load, and started automatically for you updating the feeder size for DP1. By the way, you can also change the name to anything you want to by just clicking on the name and change it to whatever you want. So I'm just going to change it to DPH to indicate for me it's, I'm sorry, it's a 480 panel. All right. So you can keep on doing this in here for all the building equipment. And then you connect them to the appropriate panel. All right, let's go now to the panel board type, which is the lighting and power panel. We set this panel previously on a 42 spaces, and it's set, we changed the voltage to 480. So we're gonna go ahead and call this guy here is lighting panel LH. Okay. All right, now in the introduction, June indicated that you can input the load either on the panel board itself or on by using the wizard. So I'm going to go ahead and demo both of them. So let's say that circuit number 1 is going to be lighting, and all we need for you or from you for the system to start calculating is 3 inputs per circuit. Input number 1 is the load in kVA. So let's say this guy is about 4 kVA, and I need the number of poles. So this is a single pole. Select 1 from the drop-down menu, and then the MAC load or the load type is the 3rd input, and the macro for it is identified by L. So it's lighting. So now the system knows that this is a lighting circuit. And by the way, a breakdown or a legend for all these macros is at the calculation portion of the panel board. It tells you that L stands for lighting, R is for receptacles, and so forth. All right. So now these are the 3 inputs that I need from you to calculate the circuit for it. Now notice what's going to happen to the trip amp and to the branch circuit and to the load once I click on calculate. Okay, so it gave you the branch circuit. It's a 20 amp, 2 number 12 ground, and a 1/2 inch conduit, and it's a copper circuit. I mean, I'm sorry, copper material, and the conductor temperature is a THHW. And then voltage drop to maintain a 3%, that circuit should not go over 144 feet. And the total amp on that particular circuit is 14.4. So that now we identified the branch circuit, at the same time identified the feeder for that panel and the main on the panel. Of course, it's only 20 amp because it's only one circuit so far. At the bottom in here, or the footer of the panel, it already classified that lighting, that load by L, so it brought it down here, demanded 125% as required by the NEC, so the demand is 5 kVA, not the connected load, and made the calculation based on the demand load. The second method to input a circuit on a lighting panel or any of the panels would be using the wizard. To get to the wizard, again, go to the control panel. On the right side of the dashboard here, you have all these buttons on the right side. These are the functions or the applications that you can apply to this panel, in particular individual panel, which is panel LH that we are on right now. So go to the wizard that says branch circuit input. It will open the window. And basically it has the 1, 2, 3, 4, 5 regions, and each region has its field. then you have the capability to modify these regions as you go. But again, all I need from you is these 3 inputs, and then all these calculations will be displayed automatically. We've already put circuit number 1 manually on the panel. So now I'm going to go to circuit number 2. And you see now it's asking me for the 3 inputs. So we're going to say the load KVA is, make it 5 this time. And then the number of poles from the drop-down menu to say this time is 2 poles. Select load type, it's still lighting. So we're going to go ahead and put an L or select an L. See, it automatically went and calculated for you in the background. You did not have to waste 2-3 seconds to do it manually on the panel board. So let's go ahead and input another circuit. So we're going to go to circuit number 3. And circuit number 3, let's go ahead and put a very large number. Let's say it's 50. And it is going to be 3 poles. And the load type, let's say this time it's a pump, or I'm sorry, like a heater or any piece of equipment. I'm sorry. And then select. So the 3 inputs is the KVA, number of poles, and the load type. Now we say, okay, now we're done with all the branch circuits. Close and calculate. And if I go back to the panel, here's circuit number 1 that we put it manually on the panel board. And then here's circuit number 2 on this side here. It's a 2-pole. So it went ahead and split the 5 kW, 2.5 on number 2, circuit number 2, and 2.5 on circuit number 4, and calculated the feeder for you. And then on circuit number 3, it divided, since it's a 3-pole circuit, it divided the load by 3 and occupied 3 spaces on the panel. And now we have the calculations down here with the demand calculations. This one, like power load is 100%. They say it's only really going to operate at 50% of the time. So you can go ahead and demand it at 50. It demanded the lighting at 125 as required by the code. Now, so, and the panel here was set on 480 to 77. Calculated the feeder and calculated the main rating. So the frame is at 100 and the mains are at 80. So the last thing that we need to do, again, is to connect that panel to the rest of the distribution system. You go to the fed from, scroll a little bit to the right, to the left, and select. And let's say this time is actually going to be connect directly to MDP and circuit number 1, submit. So now it's on MDP circuit number 1. I can go back to MDP by either clicking the circuit fed from, or I can go to the control panel, open up MDP. Here's the circuit panel LH on MDP. Now let's see what happened now with the one-line diagram. If I click back on the control panel, click on the one-line diagram, it drew the one-line diagram for me. That's the only thing that we connected to the MDP is panel LH. But we already connected things to panel DPH, so, but we did not connect panel DPH to the distribution system. So I'm going to connect DPH to MDP, to circuit number 2, submit, control panel, one line. Here's my DP1 with the running unit connected to it, all the spaces that is on DP1, and then everything is connected up to MDP, and MDP has already been updated with the correct values or the right values after we connected DPH to it. On the left side of the one-line diagram, here's the feeder. The feeder identifier by 1, 2, and 3 circles in here. and they are also in the table. I'm jumping here a little bit. I can also indicate the cables sizes next to the lines in here by clicking the option show feeder next to the hide the feeder table, apply changes. So that feeder table is gone, and now the cable sizes are on the one line diagram itself. Any questions so far? All right, so let's go ahead and add these distribution panels are actually going to be linked together. It's going to be a dual substation, dual feed substation. So I have DPH that already has some loads on it, and I'm going to go ahead and tie break it with DP2. So I go to the control panel, go to the wizard of the control panel, and down at the features in here it says link DP. Select the link DP. It's going to give you a list of all the panels that you can link it to. Right now all we have is DP2. Click on it, calculate. Now these two panels, you see the dash in between them, they're linked together through a tie breaker. If I go to the one line diagram, here's the panel DPH, here's my tie breaker, and here's DP2, okay? The only thing that we don't have, again, is how we're feeding DP2. We can go ahead and do that later on if we need to, okay? Also, I can do it now. It's DP2, and we're gonna say it's connected from MDP, and it's circuit number 3, submit, control panel, one line again. It is well, they're running on top of each other, so I need to go to the options, and you need to click on version 2, apply. It's going to go ahead and separate them, okay? It again adjusted the drafting for you automatically between the two versions. Eventually, the version 1 is going to go out of service, if you will, once we update all the databases that's out there that's been used by other people to go automatically into the version 2, okay? All right, so go back to our panels. So far, all we have is 2 linked panels, and we have a lighting panel. I don't have any power panels, but it'll be the same thing. If I go ahead and add a panel at the 208 volts, and let's say this one is going to be 24 spaces, and I keep the 208, which is the low voltage, and calculate. So now I have a panel. Again, everything is blank because we have not shown any load. We're going to call this panel here is LA. For low voltage. All right, and the methodology to input a circuit by circuit is the same way as we were doing on the lighting panel. Either you put it again on the panel board itself or go by the wizard. I like the wizard. It's much easier. It's just to go to the wizard, go to the panel board wizard. I'm sorry, not the panel board wizard, the branch circuit wizard. Control panel, branch circuit wizard. Again, circuit number 1. All I need is the 3 inputs. So let's say it's 1.2. And number of poles is 1. And it's an R for receptacles. Okay. And then I go to circuit number 2. Now this time I'm going to input an unrealistic number of kVA for a receptacle, just to show you how the system is going to do the calculations. Again, load kVA, I'm going to say this is here is 23. We all know that there is no 23 kVA receptacle. And then it is an R. And let's say that this is it for all the circuits. Close and calculate. Now I'm going to go to the panel board, LA. Circuit number 1 was 1.2. It's a receptacle. Here's the circuit associated with it. Circuit number 2 was also a receptacle, but it's 23. So you see that the feeder is, too much for a receptacle. But the reason I did that, so I can show you the calculations in the in the footer of the panel. It added up all the receptacles and then took the first 10 kW at 100% and then the remaining at 50% and calculated the demand down here. So we have a 24.2 connected load. It's demanded at 17 and calculated the panel feeder and the main rating based on the demand. Okay, this is being a low voltage panel on the low side, on the 208 side. Now I'm gonna go ahead, see there's no transformer or anything like that in here. Now I'm gonna connect this panel to a DP1 or DP2, DPH actually, okay? Now DPH is set on 480 volts. So the system have realized that there is hierarchy between the child panel, which is panel LA, and the parent panel, which is DPH, and recommended a transformer for you and size the demand based on the transformer size and increase the feeder for you, increase the main rating. If you remember, it was 80, now it's up to 90, okay? And realize that there's a transformer between the two panels. So now if I go to the one line diagram, so let's go back to the control panels and then click on the one line. Here's my one line, here's my panel LA, here's the transformer. Secondary side, the secondary side is for number 2. The primary side is number 0. And it's, well, it hasn't calculated the circuit breaker yet. It's in calculations right now. So when we get back to it, it will be there. That's it. So I showed you the equipment, panels. Now we're going to add a generator. Now, any generator will require an ATS. So I'm going to go ahead and add the generator. Okay, and then go back to my control panel. See, it's blank. There's no sizes because, again, this hasn't been connected yet. And then click on the ATS. So the ATS, you're going to need 3 inputs from you. Source number 1, which is the normal source. So click on the select. And from the drop-down menu, you need to go ahead and select which panel is going to be the normal panel for you. Let's go ahead and select DP2 and just say it's circuit number 2. Close. Load is panel LH. Now remember, LH was already connected to MDP. Now that you selected it to be connected on the ATS, it's going to automatically remove it from MDP and connect it on the ATS. All right, so panel LH now is the load on the ATS. Now we need to select the generator, which the only generator we have. You can also have multiple generators, and then you can select from them. So here's generator number 1, and it's going to be on circuit number 1, submit. So now the system automatically in the background moved LH from MDP, connected to the ATS, and sized the generator for you, did all the drafting for you on the one line diagram. So now if I go to the control panels and click on the one line, here's my generator here. It was connected on the normal side, it's connected to DP2, and the load is LH. So if I click in here on it, it's opening it up for me like that. Now, if LH was actually a low voltage panel, it will actually automatically for you put the transformer in here and size the secondary and the primary side for you. All right, and then last but not least would be the MCC. So call the MCC, you can set it up or again, leave everything on auto Don't worry about it, and let the system build its value by adding the loads. Now, this is being an MCC, so most of the loads is going to be either a motor loads, or it can be also a panel. It can be a transformer. I'm going to start with the panels, with the motors. Now, to do that, go back to the control panel. On the motor starter, click on it. It will open this page for you that you can put up to 6 motors on one motor starter. So let's say that the first motor is 7.5 horsepower, and it's a full voltage, or it can be reduced voltage. We'll be adding also the variable frequency to the list, but the variable frequency is not going to be mounted inside the motor control center. It will be outside the motor control center. So now we need to calculate the values and the NEMA size for the motor by clicking on calculate. It calculated for you the space factor and the NEMA size for that particular motor, the 7.5. Just for those who don't know how the MCC, I guess, gets designed and built, it's built in buckets. Each bucket has, I think it's a 6.5 inch in height, and then each motor starter NEMA size gets what they call a space factor. So this is here when it said 1.5 space factor. That means it's 1.5 size of a bucket. Did anybody say something? Okay. And the switch type is going to be a breaker. You also can have it in a fuse. Okay. So I'm going to just, for the heck of it, select the fuse. And right now, all I need to do is to calculate again, change the breaker to a fuse, and then I need to go ahead and select where this motor control is going to be connected to, MCC1. Okay, a NEMA size, I have a NEMA size. Okay, let's see. Okay, now let's see, MCC. All right, so these are the buckets in one column. So I'm going to select the first bucket, submit, and let's call this a pump. Oh, didn't. Okay, so MCC1, A1, submit. Okay, now control panel, MCC1. Here's my pump, and it took 3 spaces because it's 1.5, so it took 3 spaces. And here's my motor starter, here's the feeder, and it's a fuse type, and it's 25 amps. You can keep on going with that, or I can also connect a panel. As I said, you can connect the distribution panel, you can connect a transformer. Now we need to connect the MCC to the distribution system. So fed from, click on select. Again, it gives you the available information that you can connect to. So we're going to go ahead and connect it directly to MDP. You say this is on circuit number 1, submit. Now, if I go to the control panel again, go to one line, click on the one line. Here is my MCC on circuit number 1. And it updated everything associated with that particular connection. It shows you the fuse type versus the circuit breaker. Of course, I can have MCCs also tied up, just like with a tie breaker like we have with the DPH and DP1. I can have a generator. I can add panels. I can add anything I need to get my design done. I think that's it in a nutshell in terms of the type of panels. The last thing is going to be short circuit calculations. So again, go to the control panel, click on short circuit calculations. It will show you a table of the entire system. So it's from the bottom up. Here's my equipment. Here's my MDP, the distribution panels, ATCs, and so forth. And you see there is some calculations, but the AIC and the fault current is still blank because we have not started it yet. There's two ways to do the short circuit calculations, either manually or automatically. Automatically, you will have to select the transformer, or manually, if from the power company you know the fault calculations available at the transformer, you can go ahead and put it in here. So let's say it's 36,000. That's low. 45,000. Okay, enter. And then click on calculate. Now, see what's going to happen to all these blank empty cells. All right, so it calculated on my MDP. It was 45. By the time it traveled to the MDP, it dropped down to 11,000. And then that 11,000, when it went to DP2 down here, it dropped down to 4773 and so forth. Now, this said it's not that far away, but actually it shows a zero, so it's an infinite. So let's say that actually the transformer is about 100 feet from MDP. So we're going to go ahead and change it to 100 feet, recalculate. So it changed the available fault current at the transformer from the 11,000 to 21,000, and then updated everything upstream from it automatically, and also calculated the AIC for you, both at the parent panel and at the child that's sub-fed from it. Again, if anything, any of these values, most of your short circuit calculations is actually reacted to the distance of or the length of the feeder. So if your feeder is different, so let's say DP2, it calculated the feeder for the voltage drop of a 2% at 240. Let's say it's only 50 feet actually distance between MDP and DP2. You just need to go ahead and come over here, put 50 feet and calculate. Right now it says it's 6,000, now it's 14,000, and again updated everything that is connected to DPU2, updated that for you automatically. So in summary, basically you call the panel by clicking on the appropriate plus sign. You set up the panel. If it's new, leave everything on auto. If it's an existing condition, you can actually set it to that existing condition, the size of the feeder, the size of the frame, the current protection device on the panel, and so forth. And then you start working. The way it works is I need 3 inputs from you per circuit. It's the load kVA, the load type, and the number of poles. And then it will calculate the branch circuit for you and the feeder associated with it. And then you can go ahead and link the panels together. You want panel 1 to be fed from panel 2, or panel 2 fed from panel 1. You can go ahead and manipulate that for you. And every time you make a movement like that, unlink and link, relink, the system will automatically calculate everything upstream and downstream for that. It's always recommended to go ahead and have a building equipment for each of the equipment in the building, and link that piece of equipment to the appropriate panel. The system will run the voltage calculations for you based on the NEC recommendation, 2% on the feeder and 3% on the branch circuit. That's also adjustable by going into the control panel, go to the branch circuit wizard, and you can adjust the percentage down here and under the adjustment if you're not happy and satisfied. The system is also can change between the metric and the US units by again accessing the E node and go to the control panel of the E node, go to the wizard of the E node, and up here you see one of the regions is the US unit. If I go ahead and change it to the SI units and calculate, and then I'll open a panel for you. Alrighty, so let's go to one of the panels. You'll see that the size is changed to millimeter squares and the length to a meter. So the gauge changed to the metric, the length of the conductors changed to a metric. I think that's really the only two critical things. Anything is electrically, amps is an amp, a voltage is a voltage. Now, if we decided to change the voltage on this particular panel, again, go to the wizard. This is here right now, is 480. Go to the wizard, and I'll change it to 208. Calculate. It's gonna go ahead and update all the values based on that change. I think that's, cloning. We talked about cloning. To clone a panel, it's very, very easy. Again, if I want to clone panel LH, go to the control panel of panel H. On the right side, you see the buttons for the applications. One of them is clone. So if I click on it, it's going to go ahead and clone the panel for you right now. Sorry about that. I dropped my mouse. We were cloning the panel. So here's the cloning of the panel LH. If I open it, it's a replica of the exact panel. The only thing that drops out is what is it connected to, because you cannot connect two panels to the same node. So now you have to connect it to another node. That's the only thing that's going to be changed when you're cloning a panel. That's it for today. Thank you very much. And if anybody has a question.
There are a few things we did not show you today, and if you have an interest, we can touch on them in the next, another demonstration. We're always available to demonstrate for your business. We haven't shown you how to use PowerCalc for design build projects, which is a little bit different process. And also we haven't shown you our energy saving module. And we just got selected to be in the Green Building Council of Los Angeles's Net Zero Accelerator. We have office assistants filling in the panels for our projects. And then the engineers look at the input once it's available.
Now, it's not 100% linked to the application. So if there's a change, you would have to go ahead and download the panel one more time and replace the old one with the new one.
Right, because it's a PDF that you're putting onto the drawing. Right. It's uneditable. I understand.
Okay.
Well, thank you very much. I appreciate it.
You're welcome. All right.
Well, we hope to hear from all of you. If you haven't signed up for a free trial, we have a free 30-day trial. I'll be sending you the slides when we leave today's program. And we're just thrilled that you took the time and have the interest to come and meet with us. And we really enjoy talking to users. So let us know what you think and what suggestions you might have. I'm going to be sending out an email. And so you'll be certain to have our contact information. So you'll be certain to have our contact information.